Good morning, everyone. Welcome back to another exciting day in mathematics. Warm-up 79 is on your screen. You will need a calculator, so make sure grab one, send a gopher, and reads. Mr. Q was looking at the grades of one of his statistics students for this third quarter so far. They are as follows: 85, 100, 0, 100, 75, 75, and 0. Sketch a bell curve and check for outliers. Let's get started, please. I'll give you some time. All right, double check with your neighbor, see what they got. They should be done by now. Once again, you need a mean, you need a standard deviation. You need to be checking for outliers, the small and the large. And let me move this a little bit over to the left. All right, let's see. What you get for the mean, Mario? M for Mario. 47.8. Hands, have you got that? Yeah? Okay. We need a standard deviation, approximately. Tell your neighbor what you got, and then Mario's going to pass them one. Standard deviation. What'd you get for standard deviation? For the mean? Who got 62 for the mean? Yeah. I was like 47. It's like half. I'm like, all right. Let's go to 62 point what? 0.3? 62.14. Okay, I'll leave it at 14. All right, standard deviation. Mario, pass him one. Max, standard deviation. 2. Brandon Doherty, what'd you get? 43.6. Okay, that sounds about right. Hands, have you got that? All right. So then our standard deviation up, we should be at 105.74. And one standard deviation down, we should be at 18 point. Is it 54? Yeah? 1854? Something like that? Yeah? All right. All right. However, we need to check for small outliers, which means you needed to write these in order. 0, 0, 75, 70. Oh. 75, 75, 85, and 100, and 100. All right. Not bad, not bad. So, give us the formula to find the small outlier. Brandon, pass someone. Mel. Yeah. Yes. Q1 minus 1.5 times the IQR. Okay. Which means the large outlier is Q3 plus 1.5 times IQR. All right. So, small outlier, Q1. What'd you get for Q1, Mel? Pass someone. All right. Q1. All right, let's check. Q2 is 75, yes? Which means Q1 is what? 0, okay. Q3 is 100. So the IQR is Q3 minus Q1, so that's 100. So 1.5 times 100. So this is small outlier is 0 minus 150. So the small outlier that we're checking for is negative 150. Are there any negative numbers there? No. So therefore there is no small outlier. However, large outlier is Q3, which is 100 plus 150. So the large number that we're looking for is 250. Are there any numbers above 250? Nope. So there are no large outliers. All right, send that in, please. Copy the objective. Warm-up number 79 done. Intro to probability. And your home plate for tonight, pages 198, 199. And we're looking at number 17 to 21 only. 17 to 21 only. All right, and once again, reminder, grades are being closed this week so they can send out progress reports on Monday. So make sure those of you that are falling behind with some of your classes, make sure you're keeping up with your grades, especially you seniors. And January is gone. February is going to be gone pretty fast. It's telling you, right? Am I right? Am I right? All right. All right, so the warm-up 79, intro to probability, and pages 198, 199, home plate for tonight. Here's the access code for that, R3QV6. 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 That's your access to the home plate. Or you could just go home and open this one thing that looks like this, thick, and it says statistics, like a book. Somewhere like, I don't know where it's at. I need to clean my room. Anyways, get a Cornell note ready, please. Today's going to go pretty fast, so stay focused. All right. All right, just double check. This session is being recorded once again in case, for those of you that are absent, you know where to go to my YouTube channel, yes? All right, and also just a reminder, it's being recorded. Progress reports are going out when? Tell your neighbor again. When are they going out? Next Monday. Yes. For the district, so make sure you're keeping up your grades. Now, some of you that have been absent, I will give you full credit for those assignments that you turn in late. That's fine. But we already know that right now we are at 50%. So if you turn anything in late, it's 50%. So I'm just giving you a heads up. Just being a little lenient here and there with some of the scores. You guys agree? Yeah? Yeah? So once again, make sure you stay focused, especially as we're getting closer to closing this third quarter. This fourth quarter is going to go, going to get a little crazy with all the final activities for you guys the last month and a half. All right, here we go. So, where have we been? We talked about probability being the chance of an event occurring. We have the three areas that we talked about, classical, empirical, and subjective. Is that correct? Yes, Mr. Q. We closed this last Friday with an activity. For those of you that weren't here, you need to do this activity. I gave teams of 2 or 3 some things to use. I gave them a quarter. I gave them a die. I loaned them a quarter, a die. They came up with a spinner. They needed to make one on Google or get one for free on their apps. And they used that to show me all 3 different probabilities. At the end, they made a video, turned that in on Canvas, and that is going to count as a pop partay. So, what does that look like? Something like that. You guys could add different colors, different numbers, different names, and so on and so forth. From there, one side of the paper, they needed to show what classical, empirical, and subjective was using a die and a quarter. On the flip side, they needed to use a die and a spinner. using all three different areas. All right, since we now are experts at this, by now you should be able to type me in your own words what each of those are. Do that on your screen, please. I'll give you some time. What are each of the probabilities presented in front of you? Go. And they wrote classical is set probability. So basically, if you are given a coin, you already know that it's for one side to fall is 1 out of 2, and the other side is 1 out of 2. It's already set. Empirical, you actually have to go through the experiment by yourself and do all the flips to see all the different probability or the ranges as they wrote here. And the third one is, it has to do with the point of view of whatever it is the probability being presented. So that this is the least effective. So, not bad, yes? Yes, Mr. Q. All right. So, formulas, classical, empirical, and then we did an activity to show the law of large numbers. You guys remember that? Yes. That we did 2 tables on the empirical, and the more we added somebody else's numbers to our data, it started making all the outcomes and their frequencies equal to one another. So it was getting closer and closer. All right, so with that said, by now you should have all these terminologies, right? And you should know what they are. Is that correct? Yes? All right, talk it with your neighbor. Let them know what each of these are really quick. See if they remember. All right. All right. So we got these, and you should have the notes on these like so, right? Definition for all of those. Yes? All right, good. From there you wrote all rules. Now to me, these rules are just basic, how can I say, common sense. But since that's pretty much out the window right nowadays, I guess now we have to actually read the rule to make sure that we understand it. For example, rule number 1, probability of any event has to be between 0 and 1. And here they give you an inequality, 0 and 1, and in between, any probability falls within that. Could it be more than 1? No! Between 0 and 1. My goodness. All right? Rule number 2, very obvious rule, but here I'm going to read it again. It says, if an event cannot occur, think about this one. If an event cannot occur, then the probability is 0. Doesn't occur, then the probability is 0. To me, it makes common sense, but I'm reading it to you to make sure you understand it. Rule number 3, if an event is certain. For example, what is the probability of my seniors here being focused just on the lesson and not typing anything and being elsewhere during this presentation? You would say it's certain, Mr. Q, it's probability of 1. That's the most that we can get. Yes? All right. And the last one, probability rule number 4, says if we add the probabilities of all the outcomes, remember the one we did with the die? 1, 6 plus 1, 6 plus 1, 6 plus 1, 6 plus 1, 6. And all that equals 2, 1. So if we add all the probabilities for all the outcomes, it's going to be 0. Now, I'm going to give you a heads up, guys. Starting tomorrow, we're going to do like a technology detox. We're going to go old school in this class. Let's go old. So no Chromebooks, no cell phones, just paper and pencil, and just, you know, because I was trying to make you guys be senior responsibles. Yeah, maybe calculators. But it seems like I give you freedom and you guys take too much advantage of that. So I'm taking it a step back. Oh yeah, from the corner. Let's go. Copy this rule down, please. New rule. Rule of complementary events. Rule of complementary events. Yeah, I'll send it to you. Was that recorded? Yeah, it was recorded. Let's go. For all seniors to see. Go. Copy that. What is this? Not last year, previous year. I'm like, man, I could have been a singer. And the student goes, you could still be. Imagine a singer mathematician. Let's go. All right, guys, let's make a little note here. Point to the one that has a little bar, like this one, and this one. All these three with a little bar on top means they are complements. Complements. What does that mean? It means that complements the other probability to make it equal to 1. It adds up to make it equal to 1. So for example, you're on the side, write example Q. I'm going to use this final equation right here, which is the same thing as the other ones. It's just manipulated to look different. And it reads, P of E plus the complement of P of E should equal to 1. Once again, the probability of an event with its complement should equal to 1. All right. So let's say I ask the question, what is, write this down, the probability of a coin landing on tails? Of course, after you flip it, right? All right. We good? So, how do you write that? Well, I'm going to use this formula. What are they asking for? They're asking for probability of a tails. Tails. So I'm going to write P of T plus P of the complement of T, or what it is not T. So I'll just write it like this. Look up. P of T, and I'm just going to cross it out. So that's the complement of not landing on tails, right? All right. So question. What is the probability of, What is the probability of landing on tails? You flip the coin once. Tell your neighbor the probability of landing on tails. All right, Santi, go. 50 or 1/2, 1 out of 2. Because there's only 2 options, yes? Plus. Question, what is the probability of not landing on tails? What is it? 1 out of 2, yeah, because it's only 2 options. So question, is 1/2 plus 1/2 1? Yes, that is correct. You're like, what? It's a common sense formula to be used for probability. Like I said, to me it makes sense, but they need to present it like that so you guys can understand it. Let's do another one. Here we go. Example Super Q. Right. Probability of rolling a 3. And I'm talking about put D-I-E, die, 1 die. All right? So, Max, can you get that, please? If it rings again. There we go. So we write P of E plus its complement should equal to 1. Yes? So, what is the probability that we're looking for? Rolling a what? A 3. And of course, the complement is what? Oh, sorry. Hold on. Plus P of 3, but you cross it out, which means what? Not rolling a 3, yes? Equals to 1. Okay. So, think about it. We have one die. So here's the probability of rolling a 3. What is the probability of rolling a 3? 1 out of 6, yes. So therefore, 1/6 plus what gives me 1? 5 out of 6. That is correct. And does it make sense? Let's see. Rolling a 3 is 1 out of 6. How about not rolling a 3? How many numbers do I have left? 5 out of 6. From 1 to 5, how come are you with this equation? 4 5s, 4 5s, yes? All right. So, give me a second. Send me your notes. I want to see what you did, please. Then after that, copy that example, please. So, like I said, today, I'm sorry? Okay. I erased it. Here we go. Example 1. So today we're going to wrap this up for organizational purposes. Now, the past 2 weeks we've been using tables to show frequency and the total outcomes. Today I'm going to show you one different way of getting all the different possibilities, which is known as a tree diagram. Now, I'm going to give you a heads up. Some people have problems with these kind of approaches. For some of us, it's, like I said, to me it makes sense, but for some of us it does not. So, y'all ready? All right, so you wrote down example 1, build a tree diagram for all outcomes of flipping a coin 3 times. Okay, so here we go. On the far left of your paper, leave some space here, about 2-3 lines, and then draw a coin right there, like so. And then write coin. So this is our beginning right here. And at the top of it, you're going to write flip 1. So here we go. This is called a tree diagram because we're going to make a tree, but sideways. Here it goes. So, Aaron, if I flip the coin once, what are the possible outcomes? Or, yeah, heads or tails. So write that down. There it is. I'm going to switch colors. I'm going to write flip 2. However, let's say Amelia flipped it and she got a heads for the first flip, but she needs to flip it again. What are the options after flipping it a second time, everyone? Heads or tails. That is correct. But let's say I asked Alexa instead and said, Alexa, what'd you get on your first flip? Oh, I got a tails, Mr. Q. All right. So your second flip should be what, everyone? Heads or tails. Is that making sense? All right. So far, so good? All right, let's go to the flip number 3. Flip 3. So, let's say I asked Alessandro, what'd you get on your first flip? I got a heads, Mr. Q. How about on the second one? Heads. All right, let's flip it one more time. So what are the options for the third flip, everyone? Heads or tails? So far, so good, yes? So let's say I turned to Mario and I said, Mario, what'd you get? Well, I got on the first flip, Mr. Q, I got a heads. On the second flip, I got a tails. Okay, so therefore you're going to flip again. What are the possible outcomes? Again, heads and tails. Is everybody following? Yes? So far so good? All right? Does everybody see the pattern now? But let's say we went tails, heads. So what are the possible outcomes after that one? Heads or tails. Or let's say we went tails, tails. What are the possible outcomes after that? Heads and tails. All right. So how many flips? 3 of them. Are we done with the 3 flips? Yes. So let's write over here a little table. Outcomes. Total. We're going to find out all possible combinations, because that's what it says here. All outcomes, yes? All right. So follow along. I'm going to use a highlighter to make sure you're following. So I'm going to go first. Heads, heads, heads. So that's my first combo. Heads, heads, heads. However, we said we can go what? Heads, heads, tails. Is that correct? Heads, heads, heads. So I went heads, 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 tails. So notice I'm done with heads, heads, and both of these over here, so I'm done with that. All right. So therefore, what if I do this? Heads, tails. What goes first? Heads. Heads, tails, heads. Or I would go heads, tails, tails. So far so good, yes? All right. So that means I'm done with this. What would be my next combination here? Tell your neighbor. What would be my next combo? Next combo? Z says tails, heads, heads. Let's see. Tails, heads, and heads. Yes. Which means the next one is what, everyone? Tails, heads, tails. That's right here. So we're done with this one. So now we go this way. What would be the next one? Tails, tails, heads, or tails, tails, tails. Did we get all combinations? Yes. So therefore now we can find our N. How many total outcomes do we have? 1, 2, 3, 4, 5, 6, 7, 8. So our N is 8. Now, why do we need this, everyone? Because then they're going to ask you a question. Look up. Write this down. What is the probability of getting 2 tails only? 2 tails. So look at all our combinations. Let's see. The first one is heads, 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 tails, heads, tails, heads. Here is one with 2 tails. Yes. This one, no. This one also 2 tails. This one also 2 tails. Do I include this last one? No, because it has to be only 2 tails. So how many combinations? 3 out of how many? So my probability is 3 out of 8. From 1 to 5, how comfortable are you using a tree diagram? Okay, we're getting there. All right, send me your notes for this one. Let's see what you did. And copy number 2 on the screen, which reads, build a tree diagram for all outcomes of a paper, rock, scissors game after 3 turns. Ooh. You know, this one, for the sake of time, let's make it after 2 turns. 2 turns. 2 turns, because it's going to take us time to build this. All right, so I'm going to draw over here a hand. Here's my hand in a fist form. There it is. So, all right, so turn 1. All right, what are the possible outcomes, Austin P? All right, paper, rock, scissors. That is correct. That's turn number 1. But we said how many turns, guys? 2. So turn 2. So let's say Quirin gets paper on his first turn. What are the options after that? Paper, rock, scissors. Yes, that is correct. Or, if he got rock, options are what? Paper, rock, scissors. Or unless he got scissors on the first one, his options after that for turn 2, again, paper, rock, scissors. So, are we done with 2 turns? Yes. So over here we're going to write all outcomes. All right? All right, Cole, get us started. Yeah, but we're now in here. P and P, yes? PR and PS. All right, pass someone. Brandon. RP, RR, RS. Okay. Pass someone. SR, SP, SR, SS. Okay. So what is our N, everyone? How many? 9. Is that correct? Okay. All right. So, send me a picture of your tree diagram to see what you got. And as you're doing that, I'm going to show you something you're going to be like, oh yeah. All right, so on the previous one, we were looking at coins. So look up really quick. What are the possibilities of flipping a coin? What are the only outcomes, guys? How many outcomes? 2. So 2 outcomes. Do you agree with that? All right. And this one we flipped how many times? 3. So pay attention to this. 2 outcomes, 3 flips, and we get 8. Pay attention to this. Put your thinking cap on. 2 outcomes, 3 flips, we get an 8. Okay. Let's go to this one. What are the total possible outcomes on this one? 3, right? To get started. How many turns? 2. So 3, 2 turns, and we got a what? A 9. Think about it. Talk it to your neighbor, see what you see. What do you see? All right. Looks like Aaron's got this. Lulu's got this. Alessandra's got this. What do you see? Let's go with, what have we asked for a while? Amelia, what do you see? 2, starting with 2 to 3 flips gives us 8. This one we start with 3 options, 2 turns, and gives us 9. What's happening? Oh, this one is being squared, so it would be what? 3 squared, is that what you're saying? 3 squared is 9. How about this one? That one is being cubed. So what can we conclude of each of the flips or each of the turns? What is that? That becomes a what? A power. That is correct. So that means if I ask you for n after turn 3, tell your neighbor what my n would be. What would be my n? Talk to your neighbor. Everyone? 27. That is correct, because it would be 3 to the 3rd power. Yes? All right, I'm going to stop right there, guys. Once again, make sure you do your home plate, get that plenty of practice in. Those of you that are following on YouTube, make sure, once again, you get that code, do the practice, and I'll see you guys next time. Peace.